Okay, one final question that was also part of the homework, and that was question number 12. So let's have a look at this one over here. Now in this particular case you're given acceleration in terms of t. Okay, so let's just quickly jot that down. So we're told acceleration is given by 6t plus 2. So when t is equal to 2 seconds, the displacement is 10 meters. And when t is equal to 3, the displacement is 38 meters. And we want to calculate the displacement when t is 4 seconds. Okay, so it's giving you information in the question about displacement. And it's told you what the displacement is. Well, we've got acceleration. So let me go right back to the top of the page again. If we've got acceleration and we want to work out displacement, we need to integrate twice. Integrating once to give us velocity, and integrating twice to go from velocity to displacement. So what we're going to do is we're going to have to integrate twice. So for this part of the question, we're going to say, well, velocity is equal to the integral of 6t plus 2. So remember, we're integrating acceleration, and that gives us velocity. Put a dt at the end because we're integrating with respect to t. And let's see what that gives us. So that's going to give you velocity. So I'm going to use the letter v for velocity. And remember the rule for integration, you add 1 to the power divided by the new power. So that becomes 6t squared divided 2. So that becomes 6t squared divided by 2, 3t squared plus 2t. And then we have a constant of integration. And then once we've got velocity, we will need to integrate velocity to give us displacement. Now we don't know anything about this constant of integration here. There's no information about velocity in the question. So we're going to have to just keep that constant of integration in our results over here. So we're now going to say, well, displacement is found by integrating velocity. So 3t squared plus 2t plus c with respect to t. And I'm going to use, I'll just use the word displacement. X is not mentioned in the question over here. So we're going to say, well, displacement is equal to, so rule for integration, same as before, add 1 to the power, divide by the new power. So we'll get 3t cubed over 3, which simplifies down to t cubed, 2t squared over 2, which becomes t squared, c, which is a constant, it's like a number. Well, when you integrate a constant, or when you integrate a number, you get ct, so you just attach a t next to it. But then don't forget, even this end result will end up with having a constant of integration as well, which we're going to call capital D. So this is my expression for displacement in terms of t. So what are we going to do with it? Well, let's go back to the question. It says when t is equal to 2 seconds, so let's just get a colour here, nice pinky one. So when t is equal to 2 seconds, the displacement is 10 meters. So we'll set up an equation for that. So displacement is 10. So we'll say 10 is equal to, t was 2, 2 cubed plus 2 squared plus c times 2, which is just 2c, plus some number d, which we don't know. And then also, we were told that when t is 3, the displacement is 38. So we'll set up a second equation. Well, the displacement is 38 meters. That happened when t was equal to 3. So 3 cube plus 3 squared plus c times 3, which is 3c, plus some number d. Right, I just need to tidy up each of these two equations now. 2 cubed is 8, 2 squared is 4, 8 plus 4 is 12, 10 minus the 12 gives you minus 2, so in other words 2c plus d is equal to minus 2. That's equation number 1 that we've just ended up with. Similar here, 3 cubed is 27, 3 squared is 9, 27 plus 9 is 36, and 38 minus 36 is 2. So we end up with 3c plus d is equal to 2, and that's equation number 2. I'm sure you should recognize this. This is basically two linear simultaneous equations. Coefficients of d are both the same, so we can start to solve this by subtracting, and by subtracting we end up with the following. So 3c minus 2c is c, d minus d is obviously nothing, 2 minus negative 2 is positive 4, so c is equal to 4, and if c is equal to 4 we can substitute. I'm going to put it into number 2. 3 lots of 4 is 12, 12 plus something equals 2, or we can therefore say d must be equal to negative 10. So what do we do with this value for c and value for d? Well, go back to this rectangular box up here. C and d were our unknowns. We just calculated those unknowns, so we can now say therefore our displacement is equal to the following: t cubed plus t squared plus 4c plus d, which in this case is minus 10. So what we now have is our expression for displacement in terms of t. So let's go back to the question. It says find the displacement when t is 4. Well, we're ready to do that now because we know what displacement is in terms of t. So for part A of the question, when t is equal to 4, we can now say, well, the displacement is equal to 4 cubed plus 4 squared plus 4 lots of, oh yeah, that should be a t there, 4t, so 4 times 4 minus 10, and we'll put this all into your calculator. You should get 86 meters. Okay, so that'll be the answer to part A of the question. Part B of the question. Part B of the question is asking you to work out the velocity of the particle when t is equal to 4 seconds. Now we know what velocity is. Velocity was this expression here. So I'm just going to copy that down. Now if you remember, we knew what c was. We calculated c to be 4. So we can say v is equal to 3t squared plus 2t plus 4. And the question was saying find velocity when t is 4. So when t is equal to 4, the velocity v, 3 lots of 4 squared, 2 lots of 4 plus 4. So 4 squared is what? 16. 16 times 3 is 48. Plus 4 times 2 is 8. Plus 4. That makes 60. So v is equal to 60 meters per second. So that's the solutions to questions 7, 9 and 12. Hopefully that's benefited some of you who have queried about these particular questions. The key result, or the key piece of information that you need to know, is the following little diagram at the top of the page, and one crucial tip would be draw the picture. Draw the graph of v against t to help you understand what the question is really asking for. Again, it's optional, it's not necessary, but you may find it really useful when it comes to tackling questions involving variable acceleration.